Hi everyone, this is Miss B. First of all, I hope everybody is healthy and doing the best that they can during this situation. I wanted to give you an update about chemistry class for the next 2 weeks. I've sent an email home to you and your parents. I hope you read through that. Basically, everything will be completed in terms of your work through Schoology and your chemistry folders. So I will be posting on a regular basis what you need to follow along with for chem. Some of you have already completed the e-learning that I posted, so props to you. It was an article about cold, and you were supposed to answer some questions. So I did see that in your folders and have been grading it as I continue to check the folders, which I will do on a daily basis. In terms of questions, I hope your questions will be sent via email or a Google chat. During the normal school hours of 7:30 to 3:25, I will respond very quickly. But if you email me or chat me outside of those hours, I will respond, just not fast. So it may take me a day to respond to you if it's outside of those hours, or just probably by the next day. Okay, so I'd like to reserve emails and chats if you prefer that format for questions, and then your folder will be for your work. Okay, so do continue to check Schoology. Now, in terms of lessons, right now I will not be hosting any live sessions yet. If we need that format later, I will use either a Schoology conference or Google Meet to talk to you live, but for right now that's not going to happen. You will just have some lessons from me in the format of these videos, and I'll post the video file as well as a link to YouTube. I'm not sure which format your Chromebook will take, so you'll have two options to watch these videos. So I will present the lessons just like class. So you can see on your screen, this is my smartboard, right? And I've also posted your notes. I'm not going to ask you to print anything at this time. So if you want to just copy and paste this and fill it in, or just have this along so you can follow me when I explain the notes, it's totally up to you how you want to absorb the material. So this file will be provided to you as well as this file that you should be used to seeing from class time. Okay, so that is the smartboard. All right, so again, if you have any questions, just feel free to email or chat. Fair warning now with this unit, there is math, so make sure you've got a calculator with you. What I'd like to do, at least this week, is break up my units into the background info, which is this video. Then there's a video on a Q equation, which is your first equation, and then some conversions. So there's going to be 3 files for this week. So I thought it'd be a little bit easier to break up the math, because I think the background info you're going to be pretty good with, but the math is probably going to take you a little bit longer. So I thought if you start and stop those videos, it's easier if they're separated. Okay, so again, just continue to check Schoology, put your work in your folder, and then send questions as needed. Okay, there will be a progress report sent out this week, and it stops as of last Friday in terms of your work. So shout out to you guys for the test you took last Friday. You guys did much, much better as a class. A lot of you will notice you did really well on this last test. So I'm very proud of you guys. I know not all of you did well, but just as a group, you really, really tried your best. And I think that's reflected in most of the scores. So good job on that. So if you just continue to stay with me like you did on that last unit, I think you'll be okay in this current one. Okay. So just try and keep up, ask your questions as needed, and I will do the best that I can to help you out with this energy unit. Okay? All right, so I'm just going to start. If this were our class, I'd have this up on our smartboard, and I would tell you why you're learning this and break down all the components. Okay? So your last unit was liquids, solids, and those forces, right? So why do liquids and solids come together? How do they do so? Yes, they have those intermolecular forces, the dipole, the H bond, and the London, but those need energy in order to come together and make the different states of matter for any substance. Okay, so that's why you're learning energy. All right, so what energy actually is, it's the ability to do work, right? But that's kind of general. So for a chem class, we say it's the ability to produce heat. And you were supposed to be able to see that in the lab, so I will make sure that you can watch the 2 labs that we were supposed to complete online and then try and work with the data, but that's a little bit later. All right, Let's just relate this to some things that you already are familiar with. So energy is related to the mass of a substance, how much you have, and then this change in temperature, T, right? T should look familiar, that's temperature. Why does it have this triangle in front? So the triangle is called a delta, it's a Greek letter, and it simply means to subtract. So if there's going to be a temperature change, right, there's going to be a start and a finish, and we're going to subtract those two values. So I did provide this image in your notes. I thought it was a nice visual for you to understand how energy is related to some things you already know. All right, what are you looking at on the screen? So this little square with the numbers are hot plates. These rectangles with the blue liquid are beakers of, let's just say, water. Could be any liquid, but we'll just assume it's water. So what I've done here is given you some data about these different pictures, right? So M is mass, and that gram should look familiar. Delta T, right? That delta T, that triangle T, means a change in temperature. And you can tell because it says degrees Celsius. Heat. Heat is now represented with the letter Q. And I think, I'm not 100% sure, that Q was chosen because a lot of the other letters have already been taken. So I think H is used for height in physics, so that's why it's not chosen as heat in chemistry. And I think Q is not used too much, so I could be completely wrong, but that's just my guess. But Q is the letter you need to start paying attention to because it's new for us. So okay, so situation one. Beaker of water, there's 50 grams, and it increased in temperature by 10 degrees. Okay, so what, right? All right, let's move to the second picture. What if I alter this now? So in situation two, what's different? Look at how much is in that beaker. You now have 100 grams of water. Temperature change stays the same. It's a 10-degree temperature change. What will that do to the heat? So if you double the mass, what do you think is going to happen to Q? Is it going to stay the same? Is it going to increase or decrease? If it increases or decreases, by how much? And the answer to this is that it will double. So if the mass doubles, the amount of heat involved will double. Let's try situation 3. So just go down with this arrow. Now the beakers look the same, 50 grams, but now watch the temperature. It was, or temperature change, it was 10 degrees Celsius in our first situation. Now it's 30 degrees Celsius. So we have a temperature change that changed by a factor of 3. 10 degrees, now up to 30 degrees. What will that do to the heat? And the answer is, it triples it. So if temperature change tripled, heat will triple. Last situation now, diagonal arrow, situation 4. Check the beaker, you can tell there's more in there, so our mass doubled. Check the temperature change, it tripled. So we're talking from the original situation here. 50 went to 100, so that doubled. 10 degrees Celsius went to 30 degrees Celsius, that tripled. So now your mass doubled, your temperature tripled. What does that do to the heat? And the answer is, it increases by a factor of 6. So twice for the mass, 3 times for the temperature, 2 times 3 is a factor of 6, so your heat increased by a factor of 6. So what this means now, and I hope you either fill this in or just make sure you're following along, that thermal energy or heat is proportional to mass, directly proportional, and proportional to temperature change. So if the mass changes, the heat's going to change. Temperature changes, the heat's going to change. Okay. All right, so a little connection now to our last unit. So let me just block this so you don't get too far ahead of me. All right, so check out the two pictures here. This is oil, this is water. So let's say we have the same amount of each, 50 mils, just to say, and let's say we add the same amount of heat to each one of these. My question is, the oil versus the water. This oil, is it going to heat up, take in heat, faster or slower than water? The answer to this is that the oil is going to heat up faster. Now, why is this the case? Maybe you just guessed faster because you cook and you know that oil heats up pretty fast and water takes at least a good 5 minutes to start to boil. I don't know. I don't know what your reasoning was or if you even took a guess, but oil heats up faster. Now, why though? What is it that I want you to know about this? Okay, so it's a little connection from our last unit. Water has a pretty strong intermolecular force. It's got that H bond because it's H2O. Oil is in the same category as the fats in your body. And you know that oil and water don't mix. So if this is a fattier substance, it's nonpolar and it has these London bonds holding it together, which are weaker than the H bond. So oil will heat up faster because its intermolecular forces are not as strong. Okay, this is like the hand sanitizer versus water, which is going to evaporate faster, right? It's the hand sanitizer because it's alcohol based and it disappears. Water or even like lotion would take longer. All right, but now let's connect this to our current unit. So we can actually now put some numbers to this. So what I was trying to show you with the oil versus the water is that every substance has what's called a specific heat. So this is new for you now. So watch the letters. It's capital C and lowercase p, which is actually an old way to write this, but I'm old, okay? I've been doing this a long time. So this is how I was trained to represent specific heats. Some textbooks will use S, but I think that's confusing for seconds, and some will use C, and I think that's confusing for Celsius. So I stick with the old version, CP. So you're going to see that throughout my notes. Okay, so specific heat is the amount of energy a substance needs to raise a tiny piece of itself, 1 gram, a tiny degree, 1 degree. So this is like a step-by-step process. So to raise 1 gram of something by 1 degree, it's going to take energy, and that energy is called specific heat. So look at the difference now for water versus oil. Water, much higher than oil. So oil will heat up faster. It's going to take in heat faster. So water is sitting at 4.18. Oil, depending on what oil you're talking about and how hot you're going to heat it, could be between 1.67 and 2.5. So oil heats up faster. Its specific heat is lower. It takes less energy to heat it up. Now, what's with all these letters? What is this J? J is new for us. That's our unit of energy. It's called joule, not like the store. That's the man's name. You'll see him later on. G is gram, right? Because we need to raise 1 gram of a substance, and degrees Celsius is by 1 degree. So specific heat involves all 3 letters: energy, mass, and temperature. You don't have to memorize these. These will be provided to you, but you will use these later in our math equation. One last spin, one last connection from our last unit. So let's talk about just fats, right? You know, there's different types of fats. This is what we talk about in our food chem. So you have solid butter on the left versus liquid oil on the right. So who would have the higher specific heat? Who would take longer to take in its energy and heat up? So would it be the solid versus the liquid? So just trying to make you think about what you learned in the last unit, solids versus liquids. So what would your guess be? Well, the answer is the solids. So solids have stronger I shouldn't say that. They have weaker intermolecular. Okay, sorry. I was looking at something else. Okay, sorry. Let me say this one more time. So solid butter versus liquid oil. So who has the higher specific heat? So the answer to this, it is the solid. So solids have intermolecular forces that are different than liquids, right? So the solid intermolecular forces are holding them together more strongly than the liquids. So this takes a longer amount of time to overcome those forces compared to the liquid. And if you've ever cooked, liquid oil does heat up faster than butter. Butter has to melt, so there's more forces to overcome, and those values would be higher. So sorry for any confusion on this if you're listening to this, but that's why I had to pause it. My brain was thinking about something else, so I apologize. So solids have stronger IMFs than the liquids, and that's why it takes longer for those to be overcome. But again, you don't have to know these numbers. They'll be provided to you. Okay. All right, but water is a little bit funky, and I just wanted to point this out. So hopefully you've noticed that ice cubes float either in water or like soda, whatever you're putting it into. So why is that, right? Ice is a solid, so why is it floating on the water? And if you notice up here with the specific heats, liquid water has a higher specific heat than solid water. And the reason is that liquid water has those strong hydrogen bonds that break and reform really easily. But in the ice, those hydrogen bonds, you can tell they're quite farther apart, so they're going to break easily and not go back together. So it's this whole hydrogen bonding in water that gives it these funky properties. Again, you don't need to memorize this, you just need to be familiar with this topic, okay? And I will give you these values as needed. All right, so I want to give you a little background here as to the labs that we would have completed, and then I will be at the end of my first lesson here, and then my second and third will focus on the math. So let's just finish up here with your labs. So you're going to do 2 labs based on what's called calorimetry. So calorie should sound familiar, and we'll talk about calories in my third lesson. And then meter, right? So meter is something that you measure. So these were going to be meters to measure calories. So what you were going to do, you had 2 pretty cheap ones, but they're really good. So we had styrofoam cups or aluminum cans. So these are both good insulators, and you can trap the heat flow pretty well in them. So what you're going to do for the styrofoam cup, you're going to put some metals in here, trap the heat of the metals, and then calculate their specific heats, which would have been a set number. So your answer to this lab would have been a real value. And I will have a video on that. Now this picture on the right is another calorimetry lab where we would have tracked the calories in food. So if you see the aluminum can, you would have put food in the can, and then this beaker of water would have tracked the heat coming out of that food item. So the food burns, the can traps that heat, and then the water would actually feel that heat as well because it's sitting on the can, and then you see the thermometer, it would have tracked the amount of heat being burned off that food item. And then we would have converted that to calories. So I will have a video on that as well. So this calorimetry is what your 2 labs would have been based on, and you would have had styrofoam cups or aluminum cans because they're great insulators. All right, so I'm going to stop it here because this is now our math equation. So if we want to calculate heat, okay, heat is Q. The little TH, you don't have to keep writing that. That stands for thermal energy. This is heat energy, and it's equal to what now? Hopefully all 3 of these look familiar. M is mass, CP is specific heat, and then delta T is our temperature change. So we will practice these calculations in my next video.